What's up guys? For today's video, I will be going to summarize the chapter 7, which is IP addressing. So let's go. So let's proceed to the subnet mask. IPv for address. Unique IPv for address of the host. And subnet mask used to identify the network host portion of the IPv4 address. The third is default gateway. Identifies the local gateway, i.e. local router interface IPv4 address to reach remote networks. So then the unicast, the process of sending a packet from one host to an individual host as shown in figure 1. Broadcast, the process of sending a packet from the host to all hosts in the network as shown in figure 2. Then the multicast, the process of sending a packet from the host of selected group of hosts possibly in different network as shown figure 3. Special user IPv4 address. Loopback address. So, more commonly identified as only 127.0.0.1, these are special addresses used by a host to direct traffic to itself. For example, it can be used on a host test if the TCP/IP configuration is operational, such as shown in figure. Notice how the 127.0.0.1 loopback address replies to ping command. Also router how any address within this block will loop back to the local host, such as shown with the second ping in the figure. And the link local address, more commonly known as the automatic private IP address, AP or PA addresses, they are used by a window DHCP client to self-configure in the event that there are no DHCP servers available, useful and peer-to-peer connection. Then the testnet. Testnet. These addresses are set aside for teaching and learning purposes and can be used to documentation and network examples. So the legacy classful addressing. Class A 0.0.0.0.8 to 127.0.0.0.8, designed to support extremely large networks with more than 16 million host addresses. It uses a fix and 8 prefix with the first octet to indicate the network addresses and the remaining 3 octets for host addresses. All Class A addresses require that the most significant bit of the high order octet be a 0, creating a total of 128 possible classes. A network summarize the class. The second is Class B 128.0.0.0.16 and 191.255.0.0, designed to support the needs of moderate to large size network with up to approximately 65,000 host addresses. It uses a fixed 16 prefix with the 2 high order octets to indicate the network addresses, and the remaining 2 octets for host addresses. The most significant 2 bits of the high order octet must be 10, creating over 16,000 networks. So the third is Class C. The Class C is 192.0.0.24 223.225.225.0, designed to support small networks with a maximum of 254 hosts. It used to fix a 24 prefix with the first 3 octets to indicate the network and the remaining octet for the host addresses. The most significant 3 bits of the high order octet must be 110, creating over 2 million possible networks. And the figure summarized than Class C. So the IPv4 and IPv6 coexistence. So dual stacks. As shown in figure 1, dual stacks allows IPv4 and IPv6 to coexist on the same network segment. Dual stack device run both IPv4 and IPv6 protocol. The second is tunneling. As shown in figure 2, tunneling is a method of transporting an IPv6 packet over the IPv4 network. The IPv6 packet is encapsulated inside an IPv4 packet, similar to other types of data. So the third is translation. Translation as shown in figure 3, network access translation 64 NAT 64 allows IPv6 enabled device to communicate with IPv4 enabled devices using a translation technique similar to NAT for IPv4. An IPv6 packet is translated to an IPv4 packet and vice versa. So the IPv6 address types. Unicast. An IPv6 unicast address uniquely identifies an interface on an IPv6 enabled device. As shown in the figure A, source IPv6 address must be unicast address. Multicast. An IPv6 multicast address is used to send a single IPv6 packet of multiple destinations. Anycast. An IPv6 anycast address is any IPv6 unicast address that can be assigned to multiple devices. A packet sent to an anycast address is routed to the nearest device having that address anycast address are beyond the scope of this course. Global unicast. A global unicast address is similar to a public IPv4 address. These are globally unique internet routable addresses. Global unicast addresses can be addresses. Global unicast addresses can be configured statically or assigned dynamically. Link local. Link local address are used to communicate with other devices on the same local link. With IPv6, the term link refers to a subnet. Link local address are confined to a single link. Their uniqueness must only be confirmed on the link because they are not routable beyond the link. In other words, router will not forward packets with a linked local sources or destination address. So the unique local. Another type of unicast addresses is the unique local unicast addresses. IPv6 unique local addresses have some similarity. Network prefix and prefix length. Test the device which network. Default gateway address. This is an IPv6 linked local address, the source IPv6 address of the RA message. DNS addresses and domain name. Addresses of DNS servers and domain name. Verifying IPv6 address configuration. The show interface command display the MAC address of the internet interfaces. EUI 64 uses the MAC address to generate the interface ID for the linked local addresses. Additionally, the show IPv6 interface brief command display abbreviated output for each of the interfaces. The UP output on the same line as the interface indicates the layer 1 layer to 2 interface state. This is the same status and protocol columns in the equivalent IPv4 command. And the last is IPv4 TTL and IPv6 hop limit. Tracer root makes use of a function of the TTL field and IPv4 of hop limit field in IPv6 in the layer and the 3 layers head along with ICMP exceeded message. Play the animation in the figure, see how Theatriot takes advantage of TTL. So, the first sequence of message sent from trace root will have a TTL field value of 1. This cause of TTL to time out the IPv4 packet and the first router. This router then responds with ICMPv4 message. Transroute now has the address of the first hop. Thank you.